The most complicated property of the operations of arithmetic that we meet is called the distributive property. And the reason that it's complicated is that it deals with mixing, addition, and multiplication. We just call it the distributive property, but it applies to a specific mixture of addition and multiplication. Specifically, for any three numbers, a times b plus c is equal to a times b plus a times c. Now, it might help to think about this visually. Visually, we can think of multiplication as the area of a rectangle. So if we have a rectangle that's a high and b wide, so its area is a times b. And then we have another rectangle that's a high and c wide, so its area is a times c. We can imagine taping them together into another rectangle that's a high and b plus c wide, so that the area is a times b plus c. In practice, we will use the distributive property in two different ways. One way to use the distributive property is to say, if a grouping symbol is forcing us to add before we multiply, we can use the distributive property to eliminate the grouping symbol. So, for example, if we had 3 times 10 plus 2, we could use the distributive property to say, well, that's 3 times the first number plus 3 times the second number. So 3 times 10 is 30, 3 times 2 is 6, 30 plus 6 is 36. The other way that we can use the distributive property is exactly the other way round. If we're multiplying by the same thing in two places, we can combine them to multiply only once. So, for example, suppose I had 71 times 83 plus 71 times 17. That doesn't look like particularly fun arithmetic to do. But watch what happens if I use the distributive property to combine these. In the distributive property, 71 is playing the role of my a. I'm multiplying by 71 in two different terms. 83 is playing the role of my b, and 17 is playing the role of my c. So I have a times b plus a times c. The distributive property tells me that that's equivalent to a times the sum b plus c. So, looking at my numbers, 71 is my a, 83 is my b, 17 is my c. And now I notice that something good happens to me when I add 83 plus 17. 83 plus 17 is 100. 71 times 100 is 71 with 2 zeros on the end. 7,100. Again, we can check that on the calculator. We see that 71 times 83 plus 71 times 17 really is 7,100. But making use of the distributive property let us find that out more easily. This is a trick, and what we actually want the distributive property for is manipulating variable expressions. But it's a neat trick, and it lets us see why the distributive property is useful. A couple of other remarks on the distributive property. Like the associative and commutative properties, we can state this in terms of equivalent expressions. So the distributive property says A times the sum B plus C and A times B plus A times C are equivalent expressions. The other two things we need to note about the distributive property are, first, that the distributive property also works from the right. So if I have B plus C times A, I could write that as B times A plus C times A, no matter what A, B, and C are. The other thing to be aware of about the distributive property is, because subtraction is really just addition in disguise, the distributive property also works on subtraction. I could write that out the long way. If I have A times B minus C, well, I can rewrite that subtraction as addition. The distributive property says that's the same as A times B plus A times negative C. And then, using what we know about multiplying negative numbers, A times the opposite of C is the opposite of A times C. And then finally, we can rewrite that back as subtraction. That's always going to work, though, so we could just take a shortcut and just remember that A times B minus C is always going to be the same as A times B minus A times C. This is not a new property. This is just the ordinary distributive property being passed on to subtraction, because subtraction really is just addition.